Hello, Martino.
Hello, Miren.
I wanted to discuss with you how we can assess the end of life stages of facade products, as it's not always easy to understand what happens to a facade once that it reaches its end of life stage. And for that reason, I know that at Durac we have been researching new methods to assess this phase, and I know that you in the project Energy Matching in this Horizon Project 2020 develop a tool to analyze the end of life stages of the facade component. So yeah, I wanted you to explain me more about that.
Sure, sure. So I'm just sharing my screen. So the end of life tool is a tool to assess the technologies for building facade, and then the first step is doing like this so-called technological breakdown. So decompose the technologies to the macro component, that is the technologies, and then the component, and then that is a single element that composes the macro component, and then finally the element that is the single smallest element in the technologies.
Like the single material.
Yeah, like the single material, hinges, or a handle, or a single handle, or even the screws.
I see. And what does the tool consider?
Yeah, the tool, if we go to the tool, he's consider a physical characteristic as first step. So which kind of materials we have for every element and component, the presence in kilograms and the presence in percentage. So you can see in the chart that you have the percentage for the macro components, so the technology, or even for the smallest component. Then we have the section regarding the fixing system, selective separation, and their lifespan. So for every component, we have which kind of a fixing system we have, then the expected lifespan of the components, and then finally the level of difficulties to separate every component that is normally in a technology is merged together. And then regarding the circularity aspect, so the end of life tool, we focalize in the 4RS strategy potential. So we assess the potential of reduce, reuse, recycle, recover, or the disposal part of every components. Beside this, we have also the SARE and the waste codification.
So the output that the tool provides is a visualization of the 4R strategies per main elements of the facade system, and like this, you can understand which elements are hampering the 4R strategies implementations. Is this right, Martino? Maybe you can tell us when this is useful to have such information.
Yeah, yeah. This information can be very useful for instance, designer or during the development of a new product. The designer or the developer can assess their technologies first of all for the state of art. So they take their technology as it is now, they fill in the tool, and then they come up with a series of graphs that tell them in percentage or in real data, let's say kilograms or number of element, how these elements are distributed. For instance, how many percentage of reuse potentiality we have in kilograms, recycling or recover part, and so on. So it's quite useful for the design phase, first in the beginning, so as a state of art, to knowing better your product, and then in the future to try to do, let's say, sort of outlook of your element, changing some part, trying to do be more close to the reused part.
So it kind of guides you on picturing better the end of life scenarios of the facade products, and also it's useful to evaluate the impact of state of the art technology versus a more circular design approach that you might have, right?
Right, you perfect. You really take
I
the
got it.
point. You got it.
Great. So now I would be curious actually to see what did you do within the energy matching project. So I guess you use this tool for a specific technology?
Yeah, yeah. Actually, we run the analysis for 5 different technologies. The first technologies was the solar window block, that is a multifunctional facade element system that is composed by a windows, an insulating frame, and then we integrate several multifunctionalities. The first is a PV panel, then a decentralized ventilation unit system, a shading system, and then a set of battery to run all these multifunctionalities. We assess the end of life of this element, and at the state of art, we realize that only the 32% of the overall materials can be recycled. The 25% will be recovered, so means burning to produce new electricity, and then actually 43%, almost half of the materials, goes to landfill right now. So this is not acceptable for the future. And then we run an outlook working on the selective separation elements and materials, and then during the project we assess a better results.
So, which were the problematic materials that the tool revealed you that, yeah, you should reconsider somehow?
Yeah, a bigger part is composed by the PV panel and the glasses, because they are the heaviest part of the components. So actually, if you look at the windows, the IGU, so the insulated glass unit, is codified as a waste, so you cannot reuse it, unfortunately. So this is impacting quite a lot. And then of course also the insulation that is attached to the OSB panel with the glue. These really affect the possibility to separate it and then to reuse it in a further life. So this was the main challenges about this technology.
I see. Then I think that also another use that we can do of this tool that you develop is to use it maybe as a checklist if an end of life emulation test is performed, and also to evaluate the discrepancies from what you were thinking that it would be like in the design phase towards the actual end of life stage test.
Yeah, yeah, you're right. This tool, science, this tool is quite easy. You can use it in the early stage, so in the design phase, quite easily, and have an overall idea. And then, of course, if you go to produce a mock-up, to run a dismantling process in real, you can check if you foreseen correctly in the beginning, in the design phase, and then to check if the end of life tool is quite correct to the reality. So this could be very useful also.
Yeah, actually, at some point we disassembled this prototype, right? And uh, we could see this discrepancy. So, yeah, would maybe it would be nice to summarize these findings.
You're right. Actually, this analysis was done a few years ago, and then few months ago we disassembling the product, the mock-up that was, let's say, aged a bit because it was 5 years old mock-up, and then we actually we define that the landfill part is even bigger than what we expected in the beginning, because in the beginning we expected to separate the XPS panel from the OSB straw panels, but we saw that was quite difficult, even using cutters and so on, but was quite difficult. So also that part was going to the landfill. So actually I think that the tool was quite useful, but we will use it for improving a lot the technologies.
All these lessons learned can help us, of course, improve the reliability of the tool, especially by giving more information about the level of difficulty that we can have during the selective separation uh, activities for the different elements, right?
Yeah, you're right. So it's something that we are working on, and we will do it.
So, yeah, well, this is our approach at Durac to learn about what happens in the end-of-life phases of a facade systems and to quantify also the impact that that product design decision has on it. So at the end-of-life tool and experimental test of our circular labs emulating this phase aim to shed a bit of light on this and to contribute to close the loop of the envelope products. Thank you, Martino. It was really great to have you sharing your knowledge with us.
Thank you. You're welcome.
Bye bye, Martino.
Bye bye.